Union claims that the mean of its members' salary has fallen to $1,200. What a sting. A statistician subsequently conducts a random sample of 100 members' weekly salaries and calculates a mean of the sample data to be 1280 with a standard deviation of 125. So that one would indicate to you that because the sample data, so that was the mean, you could take that as the mean of the population as well. And then this one here is the sample. So this is sample, which means that we've already done 125 is equal to whatever the other standard deviation was over n, like that. We've done that, we got that. That's the sample standard deviation. That's the first little trick that might get you later. Okay, so we want to be 99% confident. Now, doesn't matter how close it is to this number, if this number, 1200, is within our confidence interval, then it's possible. If it's outside, it is not possible. So we're going to be slightly slack here, and we're going to go and use our calculator. Exit, and we're going to go. Now, we do have to note one thing before we start. As n is greater than 30, we can assume normal distribution. Now, you have to state that each time. So that's our statement that we make first. And now I can be cheeky and chuck this straight in my calculator. So I'm going to go intra z-score. I'll write this down. Intra z. We have one sample. Now we want our confidence level to be 0.99. So C level 0.99. This mitigates us not having to use or not having to calculate a z-score and then convert it. So it saves us a lot of time. Execute. Our standard deviation is 1250. Execute. Our score that we're looking for, our mean is 1280. And we've got 100 people in the sample. Execute. Okay, so that means that, let's just exit for a second so I can write this down. Standard deviation equals 125. Mean equals 1280. N equals 100. So our confidence interval is equal to 1247.8, 1312.20. So therefore, this claim is unreasonable as 1200 is outside of our 99% confidence interval. And there you go.